Hey there, Seahawks. It's Miss Adams, and in this video, we're going to talk about quantitative data and comparing distributions. All right, so quantitative distributions. A dot plot is a type of distribution that has quantitative data. It's a simple display that places dots along an axis for each case in the data set. All right, so here's an example. Some of the pros are that it's simple to make, and it shows each individual data point. Some of the cons is that it can be time consuming with a lot of data, and you have to count to get the exact total. So like if you're trying to figure out how many total elements are in this set, if they don't give you summary data, then you have to count each dot, and that can be tedious. A stem plot, also known as a stem and leaf plot, is like a histogram but shows the individual values. So we're going to make an example of a stem plot. So Babe Ruth's home run totals each season for the Yankees. So we have all of the values here. We're going to give it a title. So Babe Ruth's home runs on Yankees. We're going to have a stem side and a leaf side. When you're working with a stem and leaf plot, you always have to make a key. All right, so then on the stem side, we're going to put like the numbers that's in the tens place. So my smallest number is 22, so I'm going to put 2 in there. And then I'm going to do all of my stems. So it looks like I'm going to 60 is my largest number. All right, so then I'm going to go through. So I have a 22 and a 25, so I'm going to put the 2 and the 5. So 2 makes 22, 2, 5 makes 25. All right, then I'm going to move to my 30s. And the numbers in the 30s, I have a 34 and a 35. I move to my 40s. I have a 41, another 41, a 46, another 46, a 47, and a 49. I move on to my 50s. I have a 54, a 54, and a 59. And on my 60s, I only have one 60. So then I'm going to make my key, so I can just pick any value. I like to pick them that are actually in my stem and leaf plot. So 2, and then the line 2 stands for 22 home runs. Okay, so again, that first column is your stems, the second column is your leaves. Make sure you put them in order. Okay, and so your leaves need to go in order as you're going to the right when it's just a single set of data. All right, but they should be getting larger as you move outward, your stems. All right, and then don't put any commas. And make sure when you make your key that you include units. A back-to-back stem plot. So Roger Maris's home run totals for the Yankees are as follows. Create a back-to-back stem and leaf plot with Babe Ruth. So this is one way we can compare two different data sets. We'll make a back-to-back stem plot. All right, so home run totals with the Yankees, and I'm going to have Babe Ruth and Roger Maris. So I already have the data for Babe Ruth. I'm going to go ahead and put that in there. That's from the last problem we just did. And then Roger Maris, he has some lower values, so I have to add those stems in. So he had 8, 13, 14, 16. So see, this time as my numbers increase, again, those numbers should be getting larger as you move outward. So either to the right if you're going in this way, or to the left as you're going this way. 23 and 29, and then a 61. All right, of course, I need a key. Same thing here. You can do the key, like you can have another key. Some people like to have a key for like the right side and key for the left side. You don't have to have that. Splitting stems. So when your data is clumped together within only a few stems, it's a good idea to split the stems. Stems can be split up by 5s, 2s, or 1s. All right, another type of quantitative displays are histograms. So histograms, some of the pros are that they are visually strong. You can really see the trends happening there. They're good for describing the shape of the data. Some cons are that you cannot read the exact values because the data is chunked into groups. And it's more difficult to compare two data sets because you can't really always have that side-by-side direct comparison. You have to have two separate graphs. The bins are the bar width. So when I say bins, it's like how did you chunk them together? So this would be bins of about 25. All Histograms on the calculator. So the following are a list of test scores on an exam. You could create a histogram in your calculator. It's kind of tedious. You have to put all the data in. This is really great if you're using like a computer software too. You could do all of this, put this in. So there's something called Stapplet.com, Stapplet, where it makes graphs for you, which is very easy to use. But if you're really wanting to make a histogram on your calculator, you can put all the data in. So you go to Stat, Edit, and List feature, enter all the data in, and then you go to second y equals, which is the stat plots, and you can do that there. This is kind of what your graph will look like. Sometimes you have to adjust the windows to make it look just right. There are 4 types of histograms. You can have a frequency histogram or a relative frequency histogram. You can have a cumulative frequency or cumulative relative frequency. So frequency is where you're dealing with counts or the number. Relative frequency is where you're dealing with the percentage. Cumulative is where it's growing each time. So like if your first group had 2, your next group had 2, well then 2 and 2 would make 4. So it'd be 2, then 4, then 6. So every time it'd be growing. You're never going to see it go up and then down. It's always going to be showing growth unless it stays constant. All right, so frequencies are counts, relative frequencies are percentages, and then cumulative is it's growing each time. It's adding the previous amount to the new amount. All right, using SUCs to describe data. So SUC stands for shape, unusual features, center, and spread. So for the shape, we can either describe it as unimodal, bimodal, multimodal, uniform, skewed right, skewed left, or symmetric. And sometimes it's more of those, like it can be symmetric and unimodal. Unusual features are outliers or gaps in your data set. Center, you're either going to be describing the mean or the median, typically. Sometimes you may be using quartiles. And then the spread is the standard deviation, or the range, or the interquartile range. All right, measures of center. So the mean is the arithmetic average. We can find this by taking all of the values and adding up all the values and dividing by the number of values we have. We say that the sample mean is x bar. X with a little line over it, we say that as x bar. So this summation of x sub I is the sum of each piece, and n is the total number of pieces. The median is the middle observation. Keep in mind that these must be in order from least to greatest before you find the middle number. All right, measures of spread. The standard deviation is a number that describes how much the data varies. It's the average difference of each point from the mean. The higher the number, the more spread out the data is. All right, the equation for this, the sample standard deviation is equal to the square root of 1 over n minus 1 times the summation of each individual x value minus the mean squared. So you take each value, subtract the mean, square it, add that to the next value, minus the mean squared, and so on, and then divide by n minus 1, and then take the square root. The range is the difference between the lowest value and the highest value in the data set, and the IQR is the interquartile range. It's the difference between the first quartile and the third quartile, so quartile 3 minus quartile 1. Quartiles are basically the medians of the lower and upper half of the data. So quartile 3 is the middle of the upper half of the data, and quartile 1 is the middle of the lower half of the data. All right, the 5-number summary. We use this to describe our data set. So it's the minimum, quartile 1, median, quartile 3, and the maximum. All right, if you put all of your data into your calculator into a list, and you go to Stat, Calc, 1var Stats, it will give you the mean, the standard deviation, and it will also give you this 5-number summary if you scroll down. All right, this is great if you're going to make box plots. All right, so there's the mean is, there's the standard deviation if you're doing it on your calculator. All right, variance is the standard deviation squared, and standard deviation is the square root of the variance. If the variance is 16, then the standard deviation is 4. If the standard deviation is 6, then the variance is 36. All right, box plots are a graphical display of the 5-number summary. All right, so it's the minimum, quartile 1, median, quartile 3, and the maximum. All right. Then we can check for outliers. If you make a box plot using your calculator, it will automatically, you can have it automatically point out outliers. But one of the rules to check that we use in AP Stats is the 1.5 times the IQR rule. So we're going to basically find out where are our fences, and then anything that lies outside of those fences would be considered an outlier. So for our lower fence, we do quartile 1 minus 1.5 times the IQR. For our upper fence, it's quartile 3 plus 1.5 times the IQR. A modified box plot is if there are outliers present that they are already like distinguished. All right. And then a parallel box plot are two or more box plots that are using the same scale that you can use to compare. So a lot of times you'll have different, you collected data on 3 different things. So maybe like from this freshmen, sophomores, and seniors. And so you have their data stacked on top of each other. So you can see how it differs, but using the same scale. All right. Describing distributions, again, shape, center, spread, and then any unusual features. So unimodal means it has one peak. So the modes is like what occurs the most often. So wherever it occurs the most often, that's where you're going to have peaks because it's going to be happening the most. So unimodal has one peak. Bimodal has 2 peaks. All right, and it's just kind of like a rough shape. You're not going like, well, it went up a little bit. Okay, just vague shape. Uniform is if it's flat or relatively flat. You can see that this is not perfect, but it's relatively flat. Symmetric is where it goes up and comes back down relatively evenly on both sides. Skewed left is where the tail of your data is dragging out towards the left side. If the tail is on the right side, then it's skewed right. Outliers, you can kind of see like outliers, you'll have your data and then you'll have these other points that kind of don't fit. Gaps, you might have here's some data, then here's some data with this little gap in between. Clusters, kind of where it all happens closely together. And granulated is if it's very spread out but consistent. All right, center. We use the median when we're comparing skewed distributions or distributions with outliers. So if it's skewed right or skewed left or has very obvious outliers, we want to talk about the median when we're describing the center. We use the mean when we're comparing symmetric or roughly symmetric distributions. And then the spread goes along with what measure of center we choose. So when we use the mean, we should be using the standard deviation as our measure of spread. When we use the median, we should be using the interquartile range or the IQR as our measure of spread. All right, and then mean versus median. So in this first one, this is a symmetric distribution. So the mean, the median, and the mode are all right there at that peak. Then we have our skewed right distribution. Our mode is where it's occurring the most, so that's where our peak's going to be. And then when it's skewed, the mean gets pulled towards the skew. The mean is going to be more affected by outliers. So the mean gets pulled towards the tail. All right, so same for the left skewed. The mode is where the peak is, and the mean gets pulled towards the tail. So this time the mean would be further out. All right, go Seahawks.